Last video, we're still going to look at evaluating trig functions of any angle, but this is a pretty common situation where we're actually given one of the trig ratios up front. And in this particular case, we notice that we already know the sine value of our function is 3 over 5 here. So we're also told that it looks like here our angle is between 0 and 90 degrees. What we want to do is find the remaining trig function values that we haven't yet found. So that is to say that, well, we know our sine value is 3 over 5. Could we find the remaining trig value? So what we're going to do here is we're going to make sure that we draw a picture. And the key is that we're going to imagine that our angle is in standard position. So that is to say that standard position angles always start on the positive x-axis, have their vertices at the origin. And in this particular case, we're told that our angle lies between 0 and 90 degrees. So what I want us to do in this particular case is just draw a terminal ray that terminates somewhere between 0 and 90. I don't really mind how far into quadrant 1 you go, but we do want to indicate that our angle here is theta, and you see that it's between 0 and 90. So previously we've said as long as we have a point xy on the terminal side, then we'd be in good shape. At this point, you just draw in an arbitrary point here and you drop down your altitude, because this is going to form this triangle that we need that has an angle that terminates in the first quadrant here. So recall that given our general definition of sine, cosine, and tangent now for any angle, we know that our sine value is y over r, our cosine value is x over r, and our tangent value is y over x. The reason why it's so nice to know a sine ratio already is because technically what we've already been given are the y and the r parts of our triangle. So as we go over here and we look at this angle and we say, well, I don't really know much about it, but they did tell me the sine is 3 over 5. We know that opposite our angle, or our y value here, is 3, and our hypotenuse, or our r value here, is 5, just because it was given to us. So it seems that the only part of this triangle we're missing would be the x part, and I literally want to put an x here, not because it's something that I don't know and we give x, to things we don't know, but because this is the x letter out of all three of our letters, x, y, and r. So what we're going to do is we're just going to use our same Pythagorean relationship that we tend to use when we solve for r and we already know x and y. It's just that this time we already know y and r. We're going to work backwards for x. So we get x squared plus 9 is a 25 here. And by subtracting 9 from both sides, we kind of get x squared is 16, and take the square root of both sides, we get a plus or minus 4. Now this is an interesting situation because previously when we're solving for r, we just say, well, r is always positive, but x and y, well, man, it depends on whether you went left and right, up or down, whether or not x and y will be positive or negative. So in this case, we have to make up our minds, and this is why we draw the picture, because as we go up and look at this picture here, we say, well, look, this point that we kind of said was arbitrarily on this terminal side was in quadrant 1, and if that's the case, it has to be the positive 4 because we went right and up to get to this point here. So you put this plus or minus here, but when it comes time to actually setting up your ratios, what we're going to want to use is the appropriate one, which in this case on our picture here we put a 4 or positive 4. And so our y was a 3, our r is a 5. Given these ratios now, we could go and kind of set up the remainder of our trig ratios. We would see that our cosecant would be the reciprocal of sine, so 5 over 3. Our cosine is x over r, so since our x value is 4 and our r value is 5, we get 4/5, and therefore our secant's 5/4. And then our tangent here would be y over x. Well, our y value is a 3, our x value is a 4, and then we would get its reciprocal 4/3 as our cotangent value here. So the trick is going to be always sketching the situation first, because whenever you're given a ratio, you're already going to know 2 of your 3 sides, and you can always solve for the third, and then it just becomes our trig definitions right here that you're using. Cheers.